So to solve this problem where I would divide this imaginary fraction, divide it and then express the result in standard form. When I express a result in standard form, which means the answer that I'm ultimately going to give needs to be written as the real part plus the imaginary part. So I've got to have this written as two separate fractions. And when I am talking about dividing this, what I'm really looking at doing is multiplying by the conjugate. So when I have this problem, I'm going to multiply top and bottom by the conjugate of the denominator. So the conjugate of the denominator is going to be 3 plus 4i. And so I multiply top and bottom by the same number. And then because when we multiply fractions, we multiply numerator to numerator. So the numerator here is going to look like 5i times 3, which is going to be 15i, plus 5i times 4i, which is going to be 20i squared. And I'm not going to simplify that. I'm just going to leave it as a squared term. Now when I multiply, when I FOIL out the product of the denominator here, I'm going to multiply 3 times 3 because that's my first term, so that's going to be 9. My outer terms are going to be 3 times 4i, which would be plus 12i. My inner terms here are going to be minus 4i times 3, which is going to be minus 12i. And then the last terms here are going to be negative times a positive 4i, so that's going to be minus 16i squared. So let's simplify from here. Now remember that anytime I have an I squared, that turns into a negative 1. So I'm just going to cross that out and I'm going to put a negative 1 here, so I'll remember it. The same thing is going to happen down here. This is going to become a negative 1. So the numerator is now going to look like 15i minus 20. And it's a minus 20 because a negative 1 times 20 is a negative 20i. The denominator, notice that the plus 12i and the minus 12i are going to cancel. And I'll just put this step in here. This is going to look like 9 plus 16, because negative 16 times a negative 1 is going to be a positive 16. So one step further is going to give me 15i minus 20 all over 25 when I add 9 and 16. I'm not done yet because I'm supposed to express this in the standard form of a plus bi. So I've got to have my real components first and my imaginary components second. So we're going to come over here and we're going to split up this fraction. I'm going to write this as, we'll split it up as a fraction first. It doesn't matter which way we do this, but I'm going to look at 15i over 25 minus 20 over 25. So simplifying that further, so I'm going to reduce my fractions here. And I'm going to go ahead and I'm going to pull my real part. That's going to be this number here. That's the real portion of this. It's going to come first. So I'm going to write this as negative, what would that be, 4/5 when I reduce top and bottom by 5. So negative 4/5 plus, because the imaginary component part fraction right here is a positive 15 over 25. So it's a plus that term. So 15 over 25 reduces to be 3/5, and then I'm going to pull my I out front. So in standard form, this problem ends up being negative 4/5 plus 3/5 I when I divide the problem.